In this video, we are going to be looking at introduction to complex numbers. When we talk of complex numbers, we are referring to numbers represented in this form: z equal to a plus ib. So this is a typical representation of a complex number. So in these complex numbers here, a and b, for all a and b are elements of real numbers. A and b are real numbers, and then a is called the real part. It's called the real part, and b is called the complex part or the imaginary part. B is called the imaginary part. This is the, remember, real part, and this is the imaginary part. So this is how to represent complex numbers. And then I would like to use this opportunity to also represent this complex number on the Agar diagram. Agar diagram. The Agar diagram represented this way, where you have the y-axis and the x-axis. This is called the imaginary. The imaginary axis is the y, and this is called the real axis. It's called the real axis, which is the x. So this could be represented as z equal to x plus iy. This is the real part, and this is the imaginary part. So this is the imaginary part of the graph, and this is the real part of the graph. We're going to be looking at this more detail as we go on. I just like to bring it up here so you could get acquainted to it from the very beginning. So now, complex numbers came from the idea of square root of minus 1, right? We all know from mathematics that square root of 1 is equal to 1. But then scientists went further to do a lot of research and come up with the square root of minus 1, which is known to be I. So they thought of it in this way, that if there is square root of 1, then there should also be square root of minus 1. So square root of minus 1 is known to be I. So let's look at some other further expansion on this. So what if you have square root of minus 1 is equal to 1, then I squared, what could I squared mean? So I squared is known to be minus 1. I squared is known to be minus 1. So like for here now, if I is equal to square root of minus 1, then that means this could also be written as minus 1 is equal to 1 over 2. So I square will be equal to what? I square will be equal to square root of minus 1 multiplying square root of minus 1, which is going to be equal to minus 1 raised to the power of 1 over 2 multiplying minus 1 raised to the power of 1 over 2, which is going to be equal to, according to indices, minus 1 raised to the power of 1 over 2 plus 1 over 2, which is the same thing as minus 1. So I squared is known to be minus 1. So let's look at I raised to the power of 3. What will I raised to the power of 3 be? Now, since we have I squared to be minus 1, so this I squared multiplying I, which is going to be equal to minus I. Since I squared is equal to minus 1, then minus 1 times I is going to give you minus I. So I raised to the power of 4 will be equal to what? I squared of 4 is going to be equal to I raised to the power of 3 multiply I. And then we have it to be minus I multiply I, which is going to be equal to plus 1. Is going to give us plus 1 because I multiply I is I squared, and I squared is minus 1. So minus 1 times minus will give you 1. So I raised to the power of 5 is going to be equal to I raised to the power of 4 multiplying I which is going to be 1 multiplying I, which is equal to I. So you could do that on and on, and you have I raised to of 20, right? Or you could be asked what is I raised to of 30, what is I raised to of 12, and so on, I raised to of n. So you could be asked any of these. So if you go over this, practice it over and over, you are going to know what it's going to be like, right? So we're not going to go over and over that again. So this is going to be an assignment to you. If you just try to check out what is Iris of 20, Iris of 30, Iris of 12, and you could also play around it like that. So let's go to some simple operations of complex numbers. We told that complex number, a typical representation of complex number is like this, where this is the real part and this is the imaginary part, the real part and imaginary part. So for instance, now you are given a complex number z1. Let me change the ink. So for instance, we are given a complex number z1 to be equal to x1 plus I y1, and we are given z2 to be equal to x2 plus I y2. So what is z1 plus z2? So this is addition of complex numbers. Addition of complex numbers. We are going to have this to be x1 plus iy1, right? Writing that here, plus z2, which is x2 plus iy2. Alright, so if we do this, we're going to now take note of this. When you are adding complex numbers together, what we're going to do is we're going to add the real parts together, and we're going to add the imaginary parts together. So here we're going to have x1, this real part we add to this real part, x1 plus x2. Sorry, so plus x1 plus x2, right? Then we're going to have plus I into the imaginary part, we add the imaginary part, y1 plus y2. So that is the typical representation. So now, for instance, let's say you are giving it in numbers. You are giving it in numbers. For instance, you are giving z1 to be equal to 2 minus, okay, let me write plus 2, and then 3I here, and then you have z2 to be equal to 1 minus 2I. So z1 plus z2 is going to be equal to 2 plus 3I plus 1 minus 2I. And remember, we're adding the real parts together. If we do that, we're going to have 2 plus 1 plus, you are adding the imaginary part together, which is 3 minus 2I. And what we are going to have here is 3 plus I. So this is your answer. This is the addition of these two complex numbers. So quickly, let's go to subtraction of two complex numbers. Subtraction of complex numbers. So let's say z1 you are given. Alright, let's use the same numbers, 2 plus 3I, and then z2 you are given 1 minus 2I still. So subtracting these two complex numbers, that is z1 minus z2, we are going to have 2 plus 3I minus 1 minus 2I, which is going to be this subtracting this, the two real numbers subtracting 2 minus 1. Then we have plus this imaginary number subtracting this imaginary imaginary number is 3 minus 2 I. So what we are going to have here is 1, then this minus is plus 5 I. So this is our answer. So now, remember here we started, when we started we used a general term. So let's use a general term for it. Z1 is equal to x1 plus I, y1, then z2 is equal to x2 plus I, y2, then z1 minus z2 is going to be equal to x1 minus x2, then this plus y1 minus y2 I. So this is a general representation of subtraction of complex numbers. So next we are going to be looking at multiplication of complex numbers. So for instance, you have c1 as we have it to be x1 plus iy1, then you have c2 to be x2 plus iy2, then what is z1 z2? You are multiplying x1 plus iy1 to x2 plus iy2, which is going to be this times this x1 times x2, we have x1 x2, plus now we are going to actually multiply this across these other ones here. So we'll multiply this by this, so this by this, now we're going to have x1 y2 I, plus now multiply this by this, you have x2 y1 I, plus multiplying x1 and x2, multiplying y1 and y2, we're going to have minus, that is going to give us minus, we're going to have minus y1 y2. Remember from where we started, we said I square is equal to minus 1. It's minus 1. So if we multiply I, it's going to be I squared. So that is going to make this plus sign to be minus. So remember now, z1 z2 is going to be equal to x1 x2 minus y1 y2. Let's bring the real side different and put the um, imaginary side different. So we have x1 y2 plus x2 y1 I. So this is the real side and this is the imaginary side. So we are going to also solve examples on this multiplication. Solve an example to portrays the point more. So for multiplication now, let's say you have c1 to be equal to 2 minus I, and you have z2 to be equal to minus 1 plus 2I. So z1 z2 is going to be equal to multiply these 2 minus 1 plus 2I. So we are going to open the bracket, this multiplying this, we have minus 2, this multiplying this, you have plus 4I, then this multiplying this, you have plus I, and this multiplying this, then you have plus 2. Plus 2, this is going to be minus I squared, which is going to give 1. So this is just going to be plus 2 here. So now this, you add the real part, this plus this is going to give you 0, and this plus 5I. So z1 z2 is going to give you 0 plus 5I. That means at the real part, which is also written as real of z, you have it to be 0, and the imaginary of z, you have to be 5. So that. Now I would like us to take another example Let us to take another example. Let me change the ink. It says z1 is equal to 4 plus 3i, and z2 is equal to minus 5, um, minus 5 plus 2i. Then z1 z2 is going to be 4 plus 3i multiplying minus 5 plus 2i. Then 4 times minus 5 are going to have minus 20, then plus minus 20 plus 4 times 2i, you have 8i, and this is minus 3i times 5, minus 5, you have minus 15i, then 3i multiplying 2i, you are going to have minus 6. So minus 20 minus 6, you have minus 26. Then 8i minus 15, you have minus 13i. You have minus 13i. So this is your z1 multiplying z2. So very quickly we'll go into division of complex numbers. Division of complex numbers. Alright, in our generalized term, we have c1 to be x1 plus iy1, and then we have z2 to be x2 plus iy2. Then let's divide z1 by z2. So if you divide z1 by z2, we are going to have x1 plus iy1 dividing x2 plus iy2. So when we are to divide two complex numbers, we take rationalization of the denominator. So if we take rationalization of the denominator, we're going to have x2 minus iy2 here dividing x2 minus iy2. Then we multiply. So if we multiply this and this, we are going to have x1 x2. If we multiply x1 by iy2, we are going to have minus x1 y2i. If we multiply iy1 by x2, we are going to have plus x2 y1i. If we multiply y1 and y2, I mean iy1 and minus iy2, we are going to have plus i1 i2 dividing, multiplying x1 and x2 and x2 here, we're going to have x2 squared. Then multiply x2 by this, we're going to have minus x2 y2i, plus multiplying this and this, we have x2 y2i again, then plus multiplying this and this, we're going to have y2 squared, right? So from here you discover that minus x2 y2i and plus x2 y2i, we divide, we cancel out, right? Then we're going to have z1 z2 to be equal to, let's bring the real parts together, x1 x2 plus y1 y2, and this is going to be plus the imaginary part, right? I can as well say minus there, x1 y2 minus x2 y1 I, all divided by x2 squared plus y2 squared. So I can still split this. When I split this, I'm going to be putting the real part together and the imaginary part together. So this x1 x2 plus y1 y2 divided by x2 squared plus y2 squared. Then this is minus the imaginary part now, x1 y2 minus x2 y1 I divided by x2 squared plus y2 squared. So this is the real part and this is the imaginary part, real part of z1 over z2. This is the imaginary part of z1 over z2. So we are going to solve an example now. We are going to solve an example now to illustrate this. So let's say z1 you have z1 to be equal to 4 plus 2i, then z2 is equal to minus 1 minus I. Let's have it this way. So z1 dividing z2 will be equal to 4 plus 2i divided by minus 1 minus I, and then rationalizing the denominator we have minus 1 plus I dividing minus 1 plus I. So this implies that multiply 4 times minus 1 now you have minus 4. 4 times I, we're going to have plus 4i, then 2i multiplying minus 1 you have minus 2i, then 2i multiplying I here we're going to have minus 2, right? We're going to have minus 2. And this dividing here we're going to have 1, right? 1 multiplying minus 1 you have 1, then 1 multiplying I you have minus I, then 1 multiplying minus 1 minus 1 multiplying minus 1 you have 1, minus 1 multiplying I you have minus I, then minus I multiplying minus 1 you are going to have plus I, then minus I multiplying I you are going to have 1, right? So this is going to give us minus 6. So minus 4 minus 6 minus 6, then plus 4i minus 2i is going to give us plus 2i dividing 2, right? So if you want to split this now, z1 over z2 is going to be equal to minus 6 over 2 plus 2i over 2, which we know this is going to be minus 3 plus I. That is our answer, z1 over z2. And from here, your real part is minus 3 and your imaginary part is what is I, is just 1 there, the I. So that is real part of z1 over z2, and then imaginary part of z1 over z2. So in the next video we are going to be looking at the Agar diagram. We are going to be exploring the Agar diagram more. We'll also be looking at the conjugate of a complex number. Please like this video, share it to your friends, subscribe to this YouTube channel, and don't forget to turn on the notification bell to get notified each time we upload the video. And also, if you have a question regarding this video, you can always put your question in the comment section. Put your question in the comment section and welcome to gladly respond to it. Thank you.